There are three types of possible questions that can come in the topic continuity. The first is it continuous or not at a point? Here you will get a question like this where you will have two equations and it will be defined at different points. So for example, x for x less than or equal to 2, you have to see this equation, and for x greater than 2, you have to see this equation. And the question would be, is h continuous at x is equal to 2 or not? The second type of question would be for continuity of common functions. Here they will give you different functions and ask you which of them are continuous for all real numbers. The third one is removable discontinuity. If you remember, in calculating limits, we saw that there were one of the three scenarios. Either the limit exists, the limit does not exist, or you get a 0 divided by 0, in which case you had to manipulate the equation to find an answer. This is the same one where you just have to, the answer would always come out to be 0 divided by 0, and you have to manipulate to find an answer. Let's try solving one question from each type. For the first question, continuity at a point. H of x is equal to x minus 3 whole square, which is defined for x is less than equal to 2, and x square minus 3, where it is defined for x is greater than 2. Is h continuous at x is equal to 2? For such questions, there is a simple rule to follow, that right side should be equal to the left side for it to be continuous. If you imagine a graph, then if this is 2, right side would be values greater than 2 and left side would simply be values less than 2. For values less than equal to 2, which is the left side, the equation is x minus 3 whole square, and we will simply plug in 2 and we will get 2 minus 3 whole square, which is negative 1 whole square, which is 1. For the right side, where values are greater than 2, we have the equation x square minus 3. So we will simply plug in 2 and we will get 2 square minus 3, which is 4 minus 3, which is 1. Now here you can see that the left and the right sides are equal, which are both 1. Hence, we simply say that h is continuous at 1. For question type number 2, continuity of common functions. We have been given two functions here. The first one, g of x is equal to ln x, and the second function is f of x is equal to 1 over x. The question is, which of these functions are continuous for all real numbers? Here the tip is simply that try substituting 0 into the equation and see if the answer exists. For any function to be continuous, it has to be defined at all points. Imagine this graph, and if this is the graph coming like here, and if x is not defined at maybe 1 and it continues like this, then it cannot be continuous. Why? Because while drawing the graph, we will have to pick up our pencil and then go here. So it has to be defined at all points, and if it is not defined at all points, then it is not continuous for all real numbers. So let's try substituting 0. The first one is g of x of ln 0. Now what is ln 0? Let's jump to our formula sheet to find an answer. Here we have the functions for ln, and we see that ln of 0 is simply undefined. As ln of 0 is undefined, it means that it is not continuous for all real numbers. So we can cancel this off. Now for fx is equal to 1 over x, we can simply substitute for 0 and we will have 1 over 0. Now we already know that anything divided by 0 is undefined. Hence, we know that this is also not continuous. So none of the above functions are continuous for all real numbers. The third type of question, g of x is this equation when x is not equal to 0. G is continuous for all real numbers. Find g of 0. Now we know that the first step is simply substitution, so we'll do that. 10 multiplied by 0 divided by 0 plus 5 into 0, which is simply 0 over 0 plus 0, which is 0 divided by 0. Now as we have got 0 divided by 0, we know we have to manipulate the equation to find an answer. The first step is try taking something common. In the numerator we cannot take anything common, and in the denominator we can take x common and we'll have x squared plus 5. Now you can see that you can simply cancel off x over here and we'll have 10 divided by x squared plus 5. Now if you substitute for x again, we will have 10 divided by 0 plus 5, which is 10 divided by 5, which is simply 2. So 2 is your answer. Now coming to the question identifier. How do we know that this question is from continuity? It's very simple. Anytime a question has the word continuous, you should know that this question is from continuity. Now let's do some practice questions for each type. Continuity at a point. We know that the rule is pretty simple, which is the right side should be equal to the left side. So the first question, f of x is this equation when x is less than equal to -1, and it is this equation when x is greater than -1 and less than this value. Is f continuous at x is equal to -1? So we will simply do left is equal to right for the left one, or for values less than -1. This is the equation, so we'll substitute for -1. So we'll have 2 divided by -1 square, which is 2 divided by 1, which is simply 2. For the other side, this is the equation. We'll substitute for x and we will get -1 plus 3 divided by cos of -1 plus 1, which is simply 2 divided by cos of 0. Now let's jump towards our formula sheet to find cos of 0. Over here we can simply see that cos of 0 is 1. So we will get 2 divided by 1, which is simply 2. So we can see that the left side is equal to the right side. So if it is continuous at x is equal to -1, the answer is yes. So usually how I read the question is, I simply see, okay, there are two equations and there is a word continuity and it is asking me to find it at 0. Then I know that this value over here does not mean anything. The only thing I have to do is to simply substitute for x, which is 0, in both equations and see if the answer is same or not. So let's do that. For the first equation, it would be 1 over cos of 0, and for the second equation, it was cos of 0 plus pi. So this would become 1 over cos of 0 is equal to cos of pi. By now, I'm guessing that you would have memorized the formula sheet. So we know that cos of 0 is 1 and cos of pi is -1. So our answer is 1 on the left side and -1 on the right side. As these are not equal, 1 is not equal to -1, so it is not continuous. Our answer is simply not continuous at x is equal to 0. Question 2. There are two equations and there's a word continuous in the equation and x is equal to -5. So I'll simply substitute -3 in the equations and see if left side is equal to the right side. So on one side we have 6 divided by -3 plus 5, and on the other side we have 3 squared minus 6. So the left side would become 6 divided by 2 and the right side would become 9 minus 6. So this is equal to 3 is equal to 3, and as left side is equal to the right side, it is indeed continuous at -3. So the last question, there are two equations and there's a continuous word and it is asking for, it was supposed to be x is equal to 1. So we will simply do what we always do, left side is equal to the right side. So on one side we'll have -1 plus 1 and on the other side we'll have 2 into 1 under root. So -1 and 1 is simply 0 and on the other side under root 2 is not 0. So the left side is not equal to the right side and we can say that it is not continuous at 1.